we're going to do things just a little differently today. I'm not going to do a PowerPoint. We're going to see if that kind of helps with some of the vision and the glare and things, because I didn't have a lot of notes to give you, just more a lot of examples. And so I want to try doing it this way without the PowerPoint, and we're just because we have a lot of tables and things to draw, so that'd be easier to see. And so we're just going to, we'll see how this works. So today we're doing section 6 of chapter 6. So we're going to do 6.6. It's entitled Sequences and Expressions. So just a few definitions here that we're going to talk about. The first one is, well, we need to know what is a sequence. Well, a sequence is simply a list of numbers in a specific order. So it's a list of numbers in a specific order. Now we have what's called an arithmetic sequence, which is a specific type of sequence. An arithmetic sequence is found by adding the same number repeatedly to the previous term. So it's found by repeatedly adding the same number. So for instance, if I start with 2 and I go to 5, what did I add? Well, I added 3. So to get to the next term, I'd add 3 again and I'd get to 8. Add 3 again, I get to 11. Add 3 again, I get to 14. So on and so forth. This is an arithmetic sequence because you're adding the same thing every single time. So you just keep adding, you keep adding, you keep adding. And that's an arithmetic sequence. And the terms, those are just each of these numbers. Each number or each thing in a sequence is a term. So this is a term, this is a term, this is a term, that's a term, so on and so forth. Okay. So now we've gone ahead and looked at that. Let's go ahead and look at an example of one of these sequences. This is example number 1. Example 1. They want us to describe the value of each term as a function of its position. So what we're going to do is we're going to first draw this table. So we have position, and we have value of term. We're going to create a little table with these two things here. So we have position number 1, the value is 3. In position number 2, the value is 6. In position number 3, the value is 9. In position number 4, the value is 12. And then in position number n, we're looking for what that is. So what we're looking for is what are we doing each time to get this. So we're going to make that as a function. So if you guys remember, we did this a long time ago when we talked about functions. Remember we talked about the function machines? And we said, okay, what's happening to get this out at the other side? And we made tables just like this. That's what we're doing. We're figuring out what's happening every time for this. And this is going to be our function. It's like a function machine all over again. So what do I do to get from 3 to 6? So to go from position 1 to position 2, what am I doing to get from 3 to 6? I'm adding 3, right? So I add 3 to get from 3 to 6. What do I do to get from 6 to 9? I add 3. What do I do to get from 9 to 12? Again, I add 3. So every single time I'm adding 3. So what am I doing? So that's our sequence, or that's our pattern that we're noticing here. But how do I actually find these numbers? Notice, if I'm in position 2, how many times have I added 3? Well, I started with the 3 and I added another 3, so I have 2 3s. If I'm in position 3, how many 3s do I have? The first, and then I added 2 more, so that's 3 3s. Position 4, 4 3s. So what am I doing? I'm taking the position and I'm multiplying it by 3. So 3 times n is our function, because you're just taking whatever number this is and you're multiplying it by 3. 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. You can see how that works every single time. So really what you want to notice is here, whatever number you're adding repeatedly, that's what number you're going to multiply by. If you're repeatedly adding 3, you're going to multiply by 3. If you're repeatedly adding 10, you're going to multiply by 10. Then they ask us, find the value of the 10th term. Well, the 10th term would be out here when n is equal to 10. So what am I going to do? We want to know when n is equal to 10. So I'd have 3 times 10. And the value of our 10th term is going to be 30. So that's all that's to it, using words and numbers. So words, we're adding 3 consistently every time. And using the numbers, we're just multiplying each term by 3. Let's take a look at another example. So I'll leave that one up there for a minute. I'll erase these definitions. And we'll do example number 2. Okay. Example number 2 gives us this table. So we have positions, and we have values. This time they start us at 6. So position number 6, valued at 2. Position number 7 is valued at 3. Position number 8 is valued at 4. Position number 9 is valued at 5. And then we want to find out what is our actual function. So this time, what am I adding every time? Well, we're adding 1 each time. So that doesn't really give me too much, because all that tells me is I'm going to have 1n. But something else is happening here, because if I just put in 1 times 6, I don't get 2, do I? What do I get? I should get a 6. What have I done here? We took 6, because it's position 6, and we subtracted 4 to get 2. What did I do with this one? We took the position, I subtracted 4, and I got 3. What did I do with the next one? Position 8, subtract 4, and I got 4. So what's my function every time? We're subtracting 4 from the position number. So whatever position we're at, we're subtracting 4. So then our function here would be 1n minus 4, just n minus 4. Now again, let's find the value of n equals 10. Let's find that 10th term. So if I plug in 10, we have 1 times 10 minus 4 gives us 10 minus 4, which will give us 6. So the value of the 10th term is 6. Let's look at one more example. Okay, so they want us to make a table. It says 12 inches equals 1 foot. They want us to make a table relating the number of feet to the number of inches. So all that wants is we have inches, and then we have how many feet. So again, 1 foot gives us 12 inches. 2 feet, how many inches? 24 inches. 3 feet, 36 inches. 4 feet, 48 inches, so on and so forth. So what are we doing every time? What am I doing to the number of inches to get the number of feet? Well, how do I get from 12 to 1? I divide by 12. So 12 divided by 12 gives me 1. 24 to 2, again, dividing by 12. 36 divided by 12. 48 divided by 12. So all I'm doing every time is dividing by 12. So they ask us, I'm going to erase some of this. They tell us this girl named Rebecca, they tell us her height is 60 inches. So Rebecca is 60 inches tall. They want to know how many feet is that. What do? I take the number of inches and I do what to it? We divide by 12. So if I take 60 and I divide it by 12, we get 5 feet. So Rebecca is 5 feet tall. So we've used this pattern, we use this sequence of every time noticing. Here, notice we're adding 12 every time, so that's what we divide by to get to that other number. Okay, that concludes the lesson and the examples and things. Your homework that you'll work on tomorrow in class is going to be page 346. I'll write it over here. Page 346, numbers 5 through 18. Through 18.